Hello everyone, my name is Waffle and welcome to the 16th episode of Strats Explained, Magically Easy, a video series where I explain how and why different strats and glitches that speedrunners use work. Today we are talking about a strat called Instadeliveries in GTA Vice City. As you know, Import Export is a part of almost every GTA and Vice City is not an exception. Here we have 4 lists of 6 vehicles each, and we have to complete every single one of them because they're required for 100% completion. But there is an issue. Some vehicles' spawn points are located very far from the garage, and some vehicles don't have fixed spawn locations at all. That means you can lose a lot of time in speedruns if you don't get lucky with spawns and traffic. Luckily, there is a glitch that makes it so the game automatically delivers the bottom 3 vehicles of every list. Today we're gonna look at how it's done, find out why it works, and figure out why is it only the bottom half, why not all vehicles. As always, we will start with a demonstration. Speedrunners fill the first half of the first list manually, but the real magic begins when we start loose ends. We started in a way that we can answer a phone call from Cortez. While the conversation is happening, nobody is going to touch us. The phone call is very long, so we have time to collect everything we need. Pay attention, this mission has a lot of enemies, but the mage doesn't kill almost anybody. In fact, he mostly only kills guys on the roofs. By the time we get to the briefcase, the phone call is almost over. After that we get in the helicopter and start the mission again. Get back in the helicopter, fly around the dangerous area, land on the roof, shoot the van, and fly to the cherry popper ice cream factory. After some time we see this cutscene, which means that we successfully delivered all 6 cars from the first list. The rest is straightforward. Spend here some more time in hopes that we deliver 3 cars from the second list. Fly to Sunshine Autos and manually finish the second list. Then start the third list. Then fly back to the ice cream factory. And so on. MH was unlucky, he got only 1 car from the second list, but that's not a big deal. You just fly back and wait for a little longer. That's still faster than looking for cars in traffic. After you are done with all of the lists, grab a few packages on your way to the airport. Then pick up the second briefcase via replay and finish the mission. To be honest, I feel like after this demonstration we only got more questions. Why loose ends? Why do we not kill the enemies? How does this whole thing work? Let's find out. We are going to start with the Import Export script, because after all it is its responsibility to check what cars we have delivered already. The first thing we're gonna notice, it's called Import 1, and later there are Import 2, Import 3 and Import 4. That means that every list has its own script, but they all work the same way, so we're just gonna focus on the first one only. It starts with wait 500, and that means that this script doesn't check delivered cars every single frame, instead it does it every half a second. And every half a second it runs these checks. The first one is, if is player playing, so if our player is not dead or busted. If is player in zone Havana, if our player is in Little Havana. The next condition checks how many cars for the current list we have already delivered. If we've delivered all 6 of them, then the cutscene starts, we see our rewards. The first list is swapped with the second one. But we are interested in the opposite case, because initially there are 0 cars that are delivered, so let's see what happens there. If has import garage slot been filled, and slot number 1. And white bore slot 1 is equal to 0, so some variable flag is 0. If so, then we increase the total counter by 1, and that's the counter we just saw a moment ago that goes up to 6. We create an object, the red line in game that crosses the car off the list, and we say okay, we are done with that slot, and we set that flag white bore slot 1, the same one as you can see, to 1, meaning that we are no longer gonna be checking the first slot, we already crossed it off. And the same thing happens with the second slot, the third slot, and so on. And that's basically it, this is the whole Import Export script, very simple. What did we learn? There's just one command that is responsible for everything, has import garage slot been filled, because it is returning true for some reason for slots number 4, 5 and 6. But we can also see that these last 3 slots are checked in the exact same way as the first 3, so the issue is in some other place. Let's check the command, maybe we can find it there. Here is our has import garage slot been filled, and as you can see there is only one line, only one function call, has import export garage collected this car. The first argument is the current garage and the second one is the slot number. But pay attention, we are subtracting 1 here. Remember, in the script we saw slot numbers from 1 to 6. Here we are working with slot numbers from 0 to 5. Let's see what's inside. And inside we have, once again, only one line, but it's quite lengthy. So let's start from the beginning. Car types collected. What's that? Let's open and we see that it is an array with length of total collect cars garages, which is just 4. So we have some 4 objects, 1 object per each garage. Also, pay attention that here we say garages, not lists, and that's because when you finish the first list and go to the second one, the game sneakily changes the internal type of the garage from type 1 to type 2, then from type 2 to type 3, and so on. And when we say first garage, we mean the garage that accepts cars from the first list. So we are gonna be using these words, garages and lists, interchangeably. Okay, so we have 1 object per each garage, but what is that object? Let's go back and look at the type. Int 32, an integer, a whole number, with length of 32. So we have some number for every garage. What do we do with it? Not really sure now. Let's go back. Here we can see that we take some specific value from that array, and it is based on the garage type. So if we are currently working with the second list, with the second garage, then we get the number for that second garage. And what we are doing next is easier to explain with an illustration. Pretend we are developers and we have a task. We have 6 cars and we need to remember which ones were delivered already and which ones weren't yet. We have an obvious solution. Let's create variables for all vehicles, and then we'll need 2 values for 2 states, delivered and not delivered. Traditionally, not delivered is gonna be 0 and delivered is going to be 1. And that's it. Is it gonna work? Of course. But we also should remember that it is year 2000 and we're developing games for PS2. We want to put as much content in them as possible, so we cannot waste any memory. Having 6 variables for 6 cars is way too many. What if I tell you we need only 1 variable? How? Look at the values. It's only 1s and 0s. Does it remind you of anything? Wait, that's a binary number. In case you don't know, binary number system is almost the same as our traditional, familiar to us, decimal number system, but instead of having 10 digits, we have only 2, 0 and 1. The rest is the same. You can add, subtract, multiply them, you can convert binary numbers to decimal and vice versa. They're used in most of devices, including your computers. But we don't need any of that. For our 6 cars we need 6 bits. Each bit has its own position, and they're counted from right to left, starting with 0. Let's say you delivered the 3rd car from the list. That means that bit in position number 2, remember in code we subtracted 1, is going to change its value from 0 to 1. Therefore, to check if player delivered the 3rd car, we need to look at the 2nd bit. If the value is 1, then yes, if the value is 0, then no. And this is exactly what the second half of that long line does. It takes the current bit and then using bitwise conjunction, also known as logical AND, checks if the current car was already delivered or not. If you were watching carefully, you might have a question: why are we using 32 bits when we only need 6? C++ doesn't have any types that are 6 bits long, but it has types that are 8 bits long. And I agree, we could use them. But we need to remember that this code came from GTA 3, and in that game, import-export lists were 16 vehicles long. Still not 32, but we can imagine that back in the day, developers didn't know what the final number of cars was gonna be, so they chose 32 just in case. And when they started working on GTA Vice City, they didn't change this code, because why would you change something that already works? But back to our issue. We are not really interested in the code that is checking the bit, we are interested in the code that is changing the bit, and it is located a little bit further down. The function is called mark this car as collected for Craig, and it is very simple. There is a for loop that checks the model of the vehicle that player delivered. If that model is on the list, or there is an extra check for the police cheetah, so you can deliver it instead of a normal one. So, if the model is on the list, then we mark that model as delivered and give our players some money. If the model is not on the list, we do nothing. This code doesn't have any issues, And what is more weird, this is the only line that is changing bits in the whole code base. Looks like we reached a dead end. However, if you watched my last video about crash change, you should remember that there is a small chance, it is very small but not zero, that there is an issue in some other completely unrelated code that might corrupt some memory, and that memory very well could be the memory allocated for carriages. Now we're going to look at the BSS section. What it is and what it is used for I already explained in the second episode, link is in the description. However, what we really need to know now is that we can find our array here and see what is located near it in the memory. And there it is, car types collected. Right after it we see something called MF sprite brightness. This is something obviously related to brightness of sprites. But before it we see something called gap temp pad list. What is it? I have no clue. Let's look in REYCD. So I searched for it and there are not so many results, just 5. The very first one tells us it is also an array of pointers to pedestrians and the size is 50. The rest 4 are all located in the same place. Look, 1, 2, 3, 4, all in the same function, and it is called build ped lists. What does it do? So here are our pedestrians. The image is not very accurate. For every pedestrian here, once in 16 frames, all of that code is run. But we need to understand, since we have so many pedestrians, chances are every single frame this code is run for at least one and usually more pedestrians. So let's say in the current frame this code is run for this pedestrian. What does it do? Without going into much detail, we say that this pedestrian is the center of a circle. We'll call him central. The radius of the circle is 30 units by default. However, some missions change the multiplier and loose ends is one of them. Loose ends changes the multiplier to 2, so our radius is 60. We take all of the pedestrians inside of that circle, but they cannot be in a vehicle unless they are on a bike. So we take everyone who is on foot or on a bike. We also count dead pedestrians, but only 4 of them, because we're starting to count from 0. If there is more than 4 dead pedestrians, we count only 4 and the rest we don't count. After that, we take all of these pets and we put them in that array. We sort that array, we don't really care the way it is sorted, but for those who are curious, I checked, it's sorted by distance between the current pedestrian and the central one, from shortest distance to the biggest one. And after that, this array is no longer changed. Do you see any issues here? I think there is one that is pretty obvious. What happens if we have more than 50 pedestrians in that circle? There are no boundary checks. That means that we are going to overflow the array, and when that happens, we are going to corrupt some memory that is located after this array. What is located after this array in memory? Right, we just saw in the BSS section that after this array we have our import-export array. So we are corrupting memory for it, we're putting some values that do not belong there, and then eventually the import-export script wakes up and sees, oh, there are some new values, some new ones, player must have delivered something. Let's count these cars. To break the first gear you need 51 pedestrian, the second 52, the third 53, and the final 54. Of course you can have even more, it's still gonna work. And this is how we get these cars auto-delivered. We also need to understand that this code is not related to loose ends whatsoever. The thing you need is many, more than 50 pedestrians in that circle. By default it is smaller than this one, but there are missions that have even higher multiplier. One of the obvious places that come to mind is Club Malibu. It's not even a mission. However, there are less than 40 pedestrians there, so you need to be a bit creative with maybe rampage spawns, cops, etc. Now I'm going to tell you why it is always only the bottom half of the list. When you need to create a dynamic object, so something new when the game is already running, like a pedestrian, you need memory for that object. Where do we get it? You ask your program for it, using a function called malloc, which is short for memory allocation. So you say, yo, give me enough memory for one pedestrian, let's say 100 bytes. The program answers, hey, I have 100 bytes, now they're yours, they're starting from this address, do with them whatever you want. At the same time, malloc doesn't know if you're actually gonna put a pedestrian here, or maybe 25 numbers, or 100 characters. It doesn't know it, doesn't want to know it, it literally doesn't care. Its only responsibility is to give you that memory. What you're gonna be doing with that memory is now your problem. But does it really matter? Does it affect the address we're getting? Yes, different data types have different sizes. For example, for one character you need just 1 byte, but for one rational number of type float you need 4. To efficiently work with a variable of whatever type, the address of that variable must be divisible by the size of the type. That's just how CPUs work. So, an address of a character can be anything because any number is divisible by 1, but an address of the float has to be divisible by 4. Going back to malloc, how does it know what address to give so the CPU can work efficiently with a variable of any type? And the answer is very simple, it'll give you an address that is divisible by the size of any type. And in our case, that magic number is 8. If an address is divisible by 8, it is also divisible by 4, and by 2, and by 1. Now that we know that the address is divisible by 8, we can write that number in binary, and we will see that the first 3 bits from the right are all zeros. Meaning, no matter what number we multiply by 8, the 3 rightmost bits of the result are also going to be zeros. And this is why we cannot auto-deliver the first 3 cars of any list. It must be mentioned that the language standard establishes the minimum alignment, so the minimum number addresses must be divisible by. But nobody said it cannot be bigger, for example 16. That choice was on developers of the library function malloc. They chose 8 after all, so speedrunners should thank them for that. To fix this issue we need to understand what this array is for, why did we collect all of these pedestrians. And to be honest, I'm not interested, so I'm just gonna show you the fix by REVicity team. They say, if our array is already filled, sort it right away, and truncate, leaving only first n, so first n closest to the central pedestrians, where n is the size of m near pets array, which is 10. So we leave 10 closest pedestrians, then we continue filling that array. In the end, we sorted one more time. That guarantees that our array has at least 10 closest to the central pedestrians. And judging by the code later, that's exactly how many we need. What for? I don't know, and I don't want to know. Before we finish this one, I must mention another thing. Top speedrunners believe that pausing helps with Instadeliveries, to make them faster or more stable, whatever. I couldn't find any confirmation of that in the code, so I decided just to try it myself. I did 5 attempts without pausing and 5 attempts with pausing, and I couldn't spot the difference. In both cases I had very fast deliveries and very slow ones too. But we need to understand that 5 is simply not enough. Also, maybe I did something wrong. If you want to see my attempts, I put them all in one separate video, link is in the description. I'm not saying there is no effect, I'm only saying that I couldn't find any evidence of its presence. Maybe it helps, maybe it doesn't. This one is gonna stay a mystery for now. Alright, it's time to sum it all up. We once again faced an overflow that corrupts memory. We're actually very lucky it has a positive effect. An alternative could be a game crash like in the previous episode. The positive effect is of course import-export Instadeliveries, but only half of the vehicles get auto-delivered, and this is because how CPUs and tools that developers used work. There is also a theory, according to which pausing can speed up the process, but it did not find confirmation in the code. Yet. Does it work on any other platforms, or maybe in Definitive Edition? No, because the order of the variables in memory is different. Sometimes you can see broken lights, so-called disco lights, and it's believed that if you see these lights, there's a high chance that import-export lists are corrupted too. But how is it related? Can you explain that? This is your challenge for today. But wait a second, I have another one. Why do speedrunners kill so many enemies? We know not all of the corpses are going to be counted. Does it not reduce our chances? Leave your guesses in the comments. And this is it from me for today. A poll for the next topic is already live. Click the link from the pinned comment and choose the option you like the most. Thank you all for watching. If you enjoyed the video, leave a like, and if you don't want to miss the next episode, consider subscribing. My name is Waffle, and I'll see you the next time.